So awesome. So thanks everybody for showing up. Yeah, so this is going to be pretty cool. Looking forward to learn about CKAN and seeing what Steve's got for us. So take it away.
Yeah. Hey guys, I'm Steve Kipp. I was on the last one, the open source meetup. I thought that was super useful. John and I talked once down at T-Rex about doing this. So my job, primarily Parsons, I'm in our IR&D department, which is our internal research and development. I work primarily out of NGA, and I've done CKAN deployments for them. I've also done CKAN deployments for Bear and their competitor, Syngenta. CKAN itself, I'll get into some presentation stuff, but CKAN has been a super powerful open source tool for us. And I think its geospatial capabilities coupled with its DMS aspect, which is data management system aspect, make it very powerful in the long run. And so what I plan to do on this talk today is I'm going to take it from 0 to 100 here. I'm going to start us off with a blank Ubuntu 1604 VirtualBox. Not VirtualBox, I'm sorry, I'm doing this on EC2, but an image. And I'm going to take us all the way to CKAN in full implementation with spatial queries and the ability to interact with WMS file types. So let me go ahead and share my screen and share the keynote stuff I have. All right, let me know when you guys can see it. Okay, cool. So yeah, I called it cataloging and geospatial referencing data with CKAN. There's my email. If you guys ever need me, feel free to reach out. I can always, if you're looking to get into stuff, I can always help you. Let's see. I have to move my slide real quick. There we go. All right. So real quick, just going through kind of what CKAN is. So CKAN itself actually stands for something. It stands for Comprehensive Knowledge Archival Network, which is I think it's a very extreme name for what it does. It's a data management platform. And CKAN powers some super important sites. And I'm going to have to say, stop, you've seen this before, but I'll show you what will end up with look very similar to data.gov. And like I said before, we've implemented CKAN for companies such as Bear. We've implemented it at NGA. We've implemented it for Syngenta as well. So real quick, let me show you kind of what CKAN looks like at its full scale. I'll show you data.gov real quick. Let's see, here we go. So yeah, this is just real quick, proving to myself that I have no smoke and mirrors. There's nothing running on our Ubuntu server right now. And then there's CKAN, and I apologize, the little thing is annoying, so I'm gonna go to, we'll cover this GeoJSON stuff later. I'll also do some introduction on what GeoJSON is, how GeoJSON is structured, how to tag things via GeoJSON, and as well go into WMS file types and how they operate. So it's not just CKAN we'll cover. We'll also cover some facts of the file types that we're interfacing with. So this is CKAN at its full. You can see kind of what it looks like and how it's what we're building out. So CKAN itself is built to handle any form of data set. It's a metadata collection tool. So if you look at the hourly precipitation data, right, this comes from NOAA. It can catalog from many different sources, and it can catalog any number of things that happen to be associated with a particular data set. So you can see here some of the things it stores, right? You can see the graphic previews. And the one thing I think that's important to know about CKAN is it doesn't actually necessarily store any data itself, right? There are ways to get CKAN to do that. You can see kind of the extent, by the way, of the data set right there in the bottom left-hand corner. But I think, one thing with CKAN is it doesn't actually store any data itself. So like, if we look at the hourly precipitation landing page, right, it doesn't actually store the data on CKAN itself. CKAN is the overarching categorization and structure of this data, but it doesn't necessarily store the data itself, which I think is important to know. So in this case, you have a URL that goes to an NOAA site that has the actual data set for what we're looking for. And just, you have standard things that I think are cool across CKAN. Things like, we're going to build out this feature set right here, which is the ability to actually search via bounding box. And then that comes up with all the things that are only within that bounding box. So say, in the case of the drone data, right, if you had drone data over a certain amount of things, you'd be able to filter by actually geographically selecting that data. Again, it also does not only support WMS or things like that or GeoJSON, but it also supports XML, HTML, any sort of data set that you can give it. And we'll talk about the tagging system as we build it out. Let me go back to my slides. So this is going to be kind of in the weeds. I built this with the intent of this is a very technical topic. And so I'm going to go into kind of in the weeds of how to actually do it, how to set everything up. We're going to go from, like I said, 0 to 100. We're going to go all the way through blank to functioning. So from a technical standpoint, I'm not going to go too much into CKAN's architecture itself, but I will talk about how it kind of works. On the front end, what you saw before, CKAN uses good old Bootstrap. 3.3.6, it's actually on a relatively outdated version. And it uses Jinja 2 templating to write Python functions in HTML. I found Jinja 2 to be pretty useful. And that's kind of how you're interacting with the data side is with Jinja 2. And to run the REST API, so CKAN has an entire layer of API built on it. So every data set you do, every data set you create actually could be done entirely via command line, entirely via process, entirely, whatever. It's got an API, right? So one of the big features that we use is actually the API. So that REST API is handled by Flask and Pylons. Pylons is kind of a predecessor to Flask, and they're migrating away to a full Flask implementation for CKAN. And the database under the hood is powered by Postgres 9.5. There are newer versions out. Obviously, Postgres is at 11 now. And we'll be talking a little bit later once we get into the actual implementation. We'll be talking a little bit about the PostGIS, which goes inside of Postgres, and how to implement that and what that actually adds to Postgres as a database. So just an overarching, I keep saying so the overarching structure of this demo, intro to CKAN, which is where we're at right now and kind of what CKAN is and what I showed you. Setting up a CKAN instance on Ubuntu Xenial, which is just getting it up and running and getting the standard CKAN running, which is just data sets, not necessarily geospatial information, but just data sets at its core. And then the CKAN extensions to enable geospatial capabilities. And then we're going to talk about tagging data sets via GeoJSON, and then data set visualization via WMS and open layers. So I didn't include it on the slide, but something I would like to point out is that CKAN has extendability. I might talk about it a little bit later, but I think I do talk about it after we get a basic install, but CKAN's extendability is one of its very, very important features. Because of its open source nature, there are hundreds of plugins that are already written, and I'll show you guys that in the demo of how we can utilize open source. I'm a big open source advocate. How we can utilize the already existing plugins to not repeat ourselves and write code that doesn't necessarily need to be written, and how it makes it faster to implement. I was telling John before everyone logged on, I managed to get I timed myself before this demo, and I managed to get it completely up and running in 26 minutes and 35 seconds. And then we'll talk about which extensions you will need to run the actual the functions that we need specifically for geospatial analysis. So another thing that we could do is just talk about there are several ways to install CKAN. The fastest and the simplest is from package. A lot of you are probably familiar with apt-get. You can install CKAN from a Debian package, the same way you would install pretty much anything else. And that's how we're going to handle it for this particular installation. It'll handle some of the setup for Postgres, for Solr, for Apache 2, and Nginx. And I will stop and talk about, as I go through and do these, how each of these how much or how each of the software functions in terms of CKAN. So Solar handles our backend searching capability. Apache 2 is going to handle our primary web server, and Nginx is going to handle our caching. And it will basically only require us to set up the database, which is also automated via the CKAN command line. So typically when I do CKAN installations for clients or something like that, I do from source, which I believe Andrew's working on as we go through this, which is awesome. And this is our full control mechanism. You have full control of the source code. You have the different CKAN versions. If you need to slow the version or if you need to modify the actual source code, which you will definitely if you want to add some things to it, which is the best part of it. And the best part of open source, I think, is that you have full control over it. And that's generally used for development setups. So when you're using something in development and not necessarily in strong production, or when you're testing things, I think it's best to go with the full control, and that's requires just Git cloning. But it does require you to have a little more technical knowledge because you're going to have to do all the installs of dependencies. And then you can definitely install it with Docker Compose, but I put this is only for wizards of the container because I've worked with Docker. We've actually Dockerized CKAN on our own, but I'm not particularly good with Docker, and I'm not familiar with Docker Compose. So if you are familiar with Docker Compose, I bet it's very easy. All right, so I'm going to go ahead and get into the terminal business and walk us through installing and getting the basics of CKAN up and running. Let me share my terminal. Okay. So we're SSH'd into our EC2 at this point, and I'm going to go ahead and the first thing I'm going to do is I'm going to run apt-get update, which is just going to go ahead and check to make sure that apt is synced with all of its repositories. Now, the next thing I'm going to do is I'm going to install Nginx. Like I said earlier, Nginx is used for our backend caching. So there's two, you can be seen as there's two web servers running. Nginx is going to handle our cache for some of our spatial data and some of our resource management. Well, Apache is actually going to handle hosting the web server itself. So real quick, I'm actually going to stop Nginx because something interesting, when you install Nginx and Apache, they both run on port 80. And so if you attempt to install both of them on top of each other, neither one of them will install because they both attempt to claim port 80. So I'm going to stop the Nginx service, and then I'm going to install a lot of our, I have to move the file over here, dependencies for basic CKAN. So I'm going to go ahead and it already ran, but I was installing Apache 2, lib Apache 2 mod.wgi, libpg5, and then Redis and Git. These are all standard things that we'll need for our CKAN install. Next, I'm going to go ahead and I'm going to actually download the Debian, because remember, I'm doing this from package and not necessarily from source. So I'm actually going to download the package that is version 2.8, which is the most recent version, 2.8.2. And I'm going to download it from ckan.org and just download the Debian file. And so I'll wait while that downloads. So the way CKAN's configured, which we'll get into in a second, is it's all running through INI configuration files. So basically you'll start all these things up and then go ahead and configure all the things. So real quick, because we've had that issue before with port 80 being grabbed, I'm actually going to go ahead and we've installed Apache 2. Oops, sudo. I'm going to stop Apache 2 as well. Just because we're doing our base installs right now. So I'm going to go ahead and unpack the CKAN using DPKG, sorry, which is just the Debian equivalent for running Debian packages. So I'm going to go ahead and run that. And this, I think under the hood, this is going to run pip install. When you're installing from source in CKAN, you're going, and you can see there, it's telling me to reactivate Apache 2. When you're installing from source, you're doing a pip install, And I believe under the hood, what this is doing is pulling all the source code and also installing it as well, and then adding the additional Apache files and the Solr files and whatnot. So also I want to make clear at any time, if you guys have any questions about this and kind of how I'm doing things, I know it's kind of dry run. Feel free to stop me and just talk about what things are going on here. So next up, we've got CKAN itself installed. So I'm going to go ahead and I'm going to install Postgres. This will install Postgres 9.5 on 1604. Get that done. And Postgres itself actually isn't going to handle a lot of what we need to do. You know, CKAN has some cool things built in that will handle standard data set structure, but we'll actually have to install PostGIS a little bit later to handle the actual geospatial aspect. So I'm going to sanity check real quick, make sure that my Postgres installed correctly. It did. There are my tables. And those are your standard tables for Postgres. So now what we're going to do is we're going to start the implementation for CKAN. The first thing we have to do is create a user named CKAN default. And this is going to be the application database management user. So not the user you're going to log in as we'll show later, but this is actually what the application uses to make database calls and whatnot, and who owns the database and how you give permissions to the Postgres to our CKAN application. So I'm going to make the password CKAN, spoiler alert, because it'll come into handy later, I promise. Okay, so we've created our user. And now what we need to do is we need to create the database and specify that that user is the owner of that database. So we'll go through here and we will create DB, we'll call it CKAN default, and we'll also create the owner as CKAN default. That's kind of an important factor that can get confusing later on. Had I had named up here something later, sorry, had I had named this something different, we'd be putting a different thing down in there. We wouldn't, CKAN, sometimes it gets confusing because I'm using CKAN default as both the database and as the user, but that's just because it's an application-based user, not necessarily a user in terms of who would log in. Okay, so we've created the database and now there's nothing in there, but that's okay for right now. We have two of the four things that we need necessarily now to install CKAN itself. So the next thing, we have a database running and we have CKAN running. That doesn't give us a lot of the capability that we need, right? We still need the capability to search and we need the capability to host. So, and the database also has no tables, which we'll cover in just a second. So for this implementation, we're going to use Solr and Jetty. So it's just another simple apt-get, which will install it via Solr and Jetty. And Solr is Apache's equivalent of Elasticsearch or any of those type searching facilities. So CKAN, of course, sticking inside the open source thing, uses an open source search backend. And we'll talk a little bit later too about modifying the backend so that we can actually include geospatial data. So we're going to install Solr Jetty like that. This one can take some time because it's a relatively big package, and I think that's just how Java works. So once that's done, we'll go through and edit some Solr configuration files to make sure we're running on localhost because we're doing a single container, single image install. That's important because you can actually really, as you know, typically when you're in a production environment, right, you're not going to want to run Solr necessarily on the same server that you're running your web application on or Redis on or Postgres on, right? You kind of want to shard those out so that you have a little bit more survivability. So if one thing goes down, not everything goes down. So, and you can do that, and we'll talk a little bit about how to modify it so that we can, it's pretty straightforward to modify it so that CKAN can do that. So it looks like it finished. Now we're going to go ahead and edit some of the files here. So I'm going to open up the default configuration file for Jetty 8. And this is important. I'm going to add 2 lines in here. I'm going to add Jetty host, which is to say that we're going to run this locally. Oops, there's missing a J. That's going to set this whole thing down a path that we're going to have to debug. So we don't want to do that. So we're going to set it to localhost. And then we're going to set the standard port to show Jetty port. This is just the standard port for Solr. You can set these to any two. So say you were hosting this somewhere else, right? You might change this IP, or if you, man, it really doesn't like my J's, huh? you'd be able to run this on a different port if that port is occupied, or if you're running it in a cluster, right? You don't necessarily want to run things on different ports. This is where you would edit the port number and the IP configuration. So I'm going to go ahead and save that. Looks like our host and our port are set correctly. And then I'm going to do something that's a little confusing. So what I'm going to do here in this next line is I'm going to get rid of our actual Solar. The way Solar works is it has a map that you index through. And it's contained in an XML file, and it's called the schema. And so when Solar indexes, it uses that schema to map the object it's looking at to things it needs to search. So it comes with the default configuration schema. So what I'm going to do is I'm actually going to move that to a .back file, which is just saying, oh, don't use this, but it's still here if you need it. And I'm going to copy that over real quick. And then what I'm going to do is CKAN actually comes with its own Solar structure, right? Because like I said, with that schema.xml, we're basically telling Solar the structure to index. So we go through here and we replace the Solar schema. We create a symbolic link between the Solar schema and the link that we actually have from CKAN. So when we installed CKAN, it installs to this path. And there's a schema right here that CKAN uses. So we create a symbolic link so that Solar always links to the updated CKAN. So if we change our CKAN schema, right, if we add something new, which we'll add just a little bit later, then the symbolic link goes ahead and automatically updates the Solar schema as well. So we're going to do that, and we're good to go. So real quick, then after we've done, we're going to do a lot of this throughout the entire thing, is we're going to go and edit we're going to restart the applications because every time we make an addition, we need to usually restart them for the changes to take effect. So we'll go through here and we will restart Jetty now that we made our changes to Solar. Takes a hot second. Okay, we go in a whole new index. All right, so now we're actually going to talk about configuring CKAN to run. We've done some interesting stuff. And what we've done so far is we've created a database, we've created an index to search for, and now we need to tell CKAN, hey, here's where you should look for the database, and here's where you should be doing all your search queries on. So we're going to edit, and this file is going to come up constantly because this is where we're going to make all of our changes that actually affect CKAN itself. So we're going to edit /etc CKAN default production INI. And this will contain all of the settings for our, let me scroll down a little bit. This will control all the settings for CKAN. So you can see the host, you can change the port that it runs on, you can do all this stuff. There's some session secrets, but it doesn't necessarily matter. So right here is our first important thing, right? We created that earlier. We created that user, and we have a Postgres connection string here. And what we want to do is we want to take that Postgres connection string, and default path isn't. And what I said we made it was, oops, not in edit mode. We need to change that to CKAN, right? Because that's what I said we made our password earlier. So we set our Postgres connection string to localhost because that's where, again, we're running it all on one image. So we set our connection string to run on CKAN default, and then the database CKAN default. We need to go through, we need to enable Solar. You'll see a lot of different interesting things here. One of the things we'll do right here, it's commented out. We'll go through and we will, because you can do different backends. That's one of the important things. By default, we're using Solar, but you can actually run a lot of backends on CKAN. So in this particular case, we're using Solar. So, and that's one of the most common ones. So that's why it already exists within the configuration file. So I'm going to go ahead and I'm going to enable that and set the Solar, like we said earlier in that Jetty file, we set it to localhost, and then we set it to 8983 as the port, and /Solar is where you actually activate the schema. And then the last thing we're going to do is CKAN has to have two things to run by default, and one of them is the site URL. And the site URL is our the actual URL that we will connect to CKAN through an interface with it too. So I'm going to set it to our, real quick, I'm going to set it, let me copy our EC2. I'm going to set it to our EC2 username. And log in real quick and get our AWS stuff. And pull it out.
What was your Solar URL again? Sorry.
Yeah, it's localhost 8983/solar.
That's right. Thank you.
Let me pull this up. Okay, copied. So let me go back into my terminal. And that site URL, like I said, now this is important because this actually has to be a full string like this. Otherwise, it will complain. It has to have the HTTP and the full URL. And this basically, the way CKAN works is it appends routes to a base URL. So you give it a base URL, say something.com, right? And then when it's actually handling its routing, it's just going to append /user to whatever you set this base URL to. So if you set it to x.com, it's going to set it to x.com/user. If you set it to y.com, it's going to set it to y.com/user. And it does that just so that you can simply set base URL and then append all the functions to it and all the additional routes to it later. And the same for the API. It helps set the API routes easier. So I'm going to put our EC2 link in, and this is the one we're running right now. So we have a full site URL, which is EC2.3, and then that's our complete URL. So let me go ahead and exit out of this. And let's see, we made our changes. Let me double check. We made our changes to Solar. We've entered our CKAN Postgres. And now we have also entered our site URL. It also does have to have the site ID right down here. I didn't edit it, but it is important to note that this has to be unique across CKAN instances. So if you're running 2 CKAN instances on the same server and they are both using default, there will be a conflict. Amongst the other conflicts you'll probably have with them, that site ID does have to be unique. So let me go ahead and get out of this one real quick. So we saved that, we've exited. Our production INI is ready, but we're still missing one thing. And that is that our database has no tables in it, right? We've created the actual database, we've done that stuff, but we don't necessarily have our database tables yet. So it's there, but it doesn't have the database actual structure yet. So CKAN actually has a command line tool for this. And I'm going to invoke that real quick and say CKAN db init. So it runs through that, and this is actually creating all of our structure for CKAN. This is going to create all the tables for data sets, for tags, for users, login, stuff like that. So now that that's done, I'm going to go ahead and restart Apache 2, or start Apache 2 rather. And then I'm going to restart Nginx. So now both our web servers are running, but we have to do one last thing before we can actually implement the CKAN instance, which is that we need to add a sysadmin. So a sysadmin, when we go in later, I'll show you, this is creating a default account for our CKAN instance. This is our godhead for CKAN, right? This is the one who controls everything. So what we'll do is, oops, I don't want to do that again, but doesn't matter. We're going to use a program called Paster. This comes with CKAN. Paster is installed as a dependency with CKAN. I will say there's a note, it should be a note here. I actually need to change my location because I think if I do this, I think it will yell at me and it will say Paster is not currently installed. So you actually have to be in the CKAN space in order to invoke Paster. And then we're going to do something here. CKAN, I'm going to go into this a little bit later, but CKAN does use a virtual environment for Python. So if I ls here, you'll see that there's a bin file. So we're actually going to activate the virtual environment that gets installed earlier when we did the CKAN Debian install. And we're going to bin/activates. And boom, now we're in our virtual environment. Just real quick for people who may not be familiar, virtual environments for Python are relatively important. They keep your dependencies separate and they keep your versions of Python separate. And that may not sound like a big deal, but with applications like this, CKAN uses hundreds of dependencies via pip. And so using a virtual environment, I've had a bunch of situations where having to upgrade dependencies can cause hours worth of headaches. So it's very important to use virtual environments for this. They may not seem crucial at first, but when it comes down to it, you don't necessarily want to have to switch dependencies if you're going to create some other sort of Python application on the same server. So now this is where our stuff is usually stored. So we go into source here, and there's CKAN, which is this is where our installed everything to. So this is actual source code for CKAN. So we'll go into CKAN, and now we'll be able to run paster. So if I go back up and I run this, now it recognizes that paster is a command because we're in the actual folder and we're in the virtual environment. So I do want to create a new user admin. I'm going to make the email address local at host. If you were setting up a production instance, obviously you'd make this to a support email or something like that. It's really just a string stored. Password has to be 8 characters. That's the only default that it has. Okay, so I've created admin as a sysadmin, and that should be it for now. We restarted CKAN, so let me double check real quick. All right, so now, stop sharing my screen there. And I share Firefox. Boom. Up on our AC2 we were running earlier. There was no server running. Now we're actually running a fully functional CKAN instance. Ultimately, you know, I think that's a pretty smooth install, all things considered. You know, things like login, register, those things are handled. We can make new accounts. We can register for accounts. But remember, we already made one. And it's important that we do that, you know, so that we have some sort of default account which handles the admin stuff. CKAN has, you know, layers and hierarchy functions built into it, so not everyone can edit every organization's sets, and not everyone can edit every group's sets, stuff like that. So creating a sysadmin allows full privileges to everything. So generally, I like to create a sysadmin off the bat and then hand it over to whoever works. So remember, we named him admin. And I made his password 1234 1234. Okay, cool. So now you can kind of see, geez. Get rid of these things. Okay, so now you can kind of see we've logged into CKAN, we've created a full functioning CKAN environment, right? You can see my data sets, we don't have any, my organizations, we don't have any. CKAN has, you know, like I said, structure, so there's organizations and there's groups. And you can kind of interact with those. So an organization may be like, you know, if you have a plant division, or if you have an agriculture division, or if you have a construction division, right? You can separate your data sets into organizations and groups. Groups can belong to organizations or be independent. But you can see the feed, right? You get a news feed of everything that happened. You have user profiles. You have all this sort of stuff. And then you have, down here, you have your API keys that are built in. So whenever user signs up, you can basically specify, you know, unless you wanted to not, they get an API key, right? So everyone who accesses it by default has the API key, so they'll have the API ready. And that's pretty much it for now, right? We have our base CKAN. We can make data sets. So, you know, we could make some test data sets. Let's go through real quick because I think I'm a little ahead of schedule, and I'm going to make a data set, and it's going to yell at me for a hot second here. You can't create a data set before you create an organization. So all data sets have to belong to some sort of organization. So I'm going to call this Steve's organization, which you see I've done in my tests earlier today. And I'm not really going to do anything else beyond that. You can give a description, you can put an image in it and all that stuff, but this is, you know, we're on a time crunch, so I'm not going to do anything. Create organization. And again, like I said, up here at the top, you see how that base URL we set, man, a Zoom thing keeps popping up. That base URL we set up at the top there, that's the site URL we set in the CKAN INI. And then that is the actual function and route that gets appended to that. And if we had more time, I'd talk about the templating function of Jinja, but basically you're able to invoke this URL anywhere you need to because it's specified. And I think that's super important. So let's see. Going down there, now we also need to, now we have an organization, we can add data sets. You can kind of follow organizations, which will give you periodic updates of what they're posting and whatnot, which I think is pretty cool. But let's add a data set. So we have a whole bunch of information fields that we can add, right? So I'm gonna call this Steve's basic data set. I'm not going to put any description in because I don't have any real data set to put in here. You can tag it with whatever you want, Steve, right? You can tag all sorts of things. You can add additional tags. And as we go into the geospatial stuff later, I will tag some stuff geospatially. right now, it belongs to Steve's organization. By default, things are set to private. I set them public just because that's easier. Source version, you can enter all these. They're not required. That's an important thing. As we get down here later, you can add any set of custom things here. You could say like, you could set it to anything here. And this is actually where later on we will add our geospatial capabilities. We'll add our spatial keys and our GeoJSON down here in our extra keys. But next we'll add data. So I don't have any data to add, obviously, until we get into our WMS stuff later. But so I'm gonna make a fake website, which I've used before, which is websitewithmydata.com/data. And then I could name it whatever I want, data. And then description, and then here's where you can tag the format. So if you wanted to say, let's say this is a CSV, we'll put that in there, finish. And here's Steve's basic data set. You have the tag Steve, you have the data set. Each data set has a resource, which is actually the data. And then there's the overarching information about it. So you can see the state is active. You can see when it was last updated, created, and then that field I created is good. Yes. So you can see a lot more about that. And later on, we'll get into this exploratory where you can actually preview and download the data from what we get. So real quick, I'm going to stop sharing and go back to my Keynote thing. Does anyone have any questions? I know I'm going like light speed here. Sweet. Okay, so CKAN extensions. This is one of the things I talked about earlier that I think is super important. CKAN is very extendable. It has an entire Python library built into it that allows you to extend and use its existing functionality and as well add new functionality. We've made plugins and extensions for CKAN that post to Yammer every time a data set is updated or post to Slack. We've created Slack bots that run on top of CKAN. This is where you typically use that kind of stuff. And we're going to use three particular extensions. Sorry, I sometimes confuse extensions and plugins in my head. We're going to use three particular extensions that will enable the geospatial features that are already written for CKAN. This saves a lot of time for us to go through and do this. So we're going to enable the spatial plugin. We'll enable the spatial search plugin, and then we'll enable the spatial viewer plugin, which adds some of the templating information and the WMS requests. And now spatial handles the tagging, and it adds postages. Spatial search will extend the Solr capability to index spatial data, which will give us the search functionality we saw earlier. And then spatial viewer, like I said, will give us the information to, or the ability to view WMS and interact with WMS inside of CKAN via open layers. Okay, so I will go on now to install the extensions. Let me go ahead, whoops, and go back to sharing. Oh, look at that. Andrew already got it with Docker Compose. You container wizards, man. It's too much. You make things look too easy. All right. So going back to my terminal. I'd like to see sometime, Andrew, how you did that, because we've Dockerized it for instance before, but I've never run it with Docker Compose, and I have no experience running Docker Compose at all. So
yeah, it was really easy.
Oh, sweet. Yeah, if we have time at the end of this, I would love to see that. Okay, so we'll go ahead and first things first, we have to install PostGIS. And that's an extension for Postgres, which adds things like spatial queries and a lot of geospatial functionality, referencing systems, latitude, longitude, stuff like that. So basically it adds a bunch of tables that have a bunch of functions. It's an extension of Postgres, so it's a pretty quick app to install. A lot of stuff that goes with it. So once that's installed, this is basically just downloading the libraries that are necessary for it, and then we'll actually have to go through and run the extension for Postgres and show Postgres to add the actual tables that are required for the geospatial data to be held. So we have to install the basic PostGIS, and then we actually have to install the spatial referencing system as well. So Andrew, this might be a good part too. If you want to hop in here, this is a good place to install the extensions.
All right.
Because you should be right on par because we already have CKAN up and running. So this should be a good place to install the extensions. So here, now we have PostGIS installed for Postgres 9.5. So we're going to go ahead and invoke Postgres with pSQL, and using it with database user CKAN default, we're going to run the actual PostGIS script and create those tables to Postgres. And this will modify to our CKAN default database. So there we go. You see it created a bunch of function, creates rules. Obviously, as much as you'd love for me to all sit here and explain every single function that it installs, take my word, it's a lot of geospatial functionality. And then second, we'll need to install the spatial reference system, which is another thing that comes with Postgres, which does a bunch of inserts and tests and things like that. So it gives it some spatial referencing. So we went through there and did that. Now, the next thing we have to do is important because we've installed these things to Postgres, right? We've extended it so that we have these geospatial tables. Now we need to go through and we need to alter these tables so that they're owned by CKAN default. We've put them on the table, but we don't necessarily, we put them into Postgres as functions and callable tables, but we don't necessarily have them owned by CKAN default yet. So we'll change those real quick in order to do that. And so real quick, I'm going to do a sanity check, make sure that my Postgres and PostGIS is installed. So we should be able to do this. It will give us the full PostGIS version, which is 2.2.1. Geos is installed and libjson. So this is kind of how it interprets things. We will install here some additional dependencies for our geospatial extensions. So this is going to apt-get install Python dev, libxml2 dev, and then libgeos. These are all functions that our extension geospatial will need to run. There we go. In order to run some of the spatial queries that we want to. And I will say an important note. Their documentation for installing this, which we'll talk about in a second, we're going to install the actual extension. Their documentation is only supported for Ubuntu 14.04. So there are some modifications you have to make to some commands, which I've already made. And so if you need help with that, again, I told John, I can put this all in a script so everyone can see all the changes I made, and I can post my notes. But you will have to make, in order to get the geospatial stuff up and running, especially if you're using 16.04 or greater, you do have to make some modifications to their documentation for the spatial referencing. All right, so we've started the virtual environment. We're already there. So now what we're going to do is we're going to go into here and do something you should never do, but for the purpose of this demo, I'm going to do it. Sorry, I have to go back one more. We have an issue where occasionally the dependencies do not get installed correctly, and they have permission denied issues, which means we can only do one rational thing, which is to let everyone read it. This is not something you should do. I want to make it very clear. This is nothing you would ever do in production. But for the purpose of this, I'm not setting it to my particular user or anything like that. It's a quick fix so that we can show the demonstration of the features here.
So what would be the production type fix? Obviously, we're not going to do it. But what is the best?
Yeah, I think what you would do is you would set it to you wouldn't be logging into Ubuntu. You'd have a CKAN user, and then what you would do is rather than doing 7, you would use 650, which I believe sets it, or 600. I'm not particularly good with chmod, but you'd set it to your user so that only your user has access to install from there. Because when we're installing these, you'll see next, I'm going to install it with pip. We're going to install it as the, oops, I want to do it again. We're going to install it as the user and not as root. And so that's part of the issue it doesn't like, is because technically we're in user lib and CKAN. And so it doesn't like that when we go down there and we attempt to install it, I'll show you here, it's going to put things in a certain directory, which is right here. And that directory is usually covered. And normally you could do something to install, we've been doing up until now, we've been doing a lot of sudo apt-get. And this particular function, when I was running it earlier, gave me an issue with permissions. So like I said, normally I would set it so that chmod sends to just my user and not necessarily everyone, which is, again, bad idea. Okay, so now what we've done is we've installed the CKAN ext spatial. This is a CKAN extension, and this has a lot of the functionality that we're looking for. So now we've installed that, right? We've installed our base one. We actually need to go through, we need to actually install the requirements, which is the dependencies as well. So they have a pip requirements text. So we go through and we'll do this, and it will install all of the dependencies that we need for it. So you can see the dependencies are libxml, geoalchemy. If you're not careful, you can get stuck down some pretty rough roads there in dependency hell. So it's important just to that's why the virtual environment is so important, is to maintain the geospatial functionality in just that particular package and never upgrade or downgrade it, because those functions do change. So real quick, sanity check, I'm gonna go ahead and reload Apache 2, make sure everything's still running. And I'm gonna go back to our beautiful production file and go ahead and add some of the extensions. We've downloaded them and we have them here. So if I go back into CKAN default source, right? Now you can see what used to just be CKAN is now also CKAN ext spatial. So we could have just done a git pull, or a git clone, I'm sorry, git clone here and pulled down CKAN ext spatial, right? It's the same thing, but we've just installed it via pip, and its pip install actually puts it in this directory, which is the default source. So all of your source files for CKAN, all your extension, where you do all your work is here under user lib CKAN default source. So I'm going to go in there, and then what I'm going to do is I'm going to, again, reopen our production file. And this is, again, our overall CKAN configuration. So we're going to edit some of these lines again, because now we have these installed, right? We need to make them active in CKAN. So you'll find a line down here in the production INI, which has CKAN plugins right here. I should turn on my Vim line numbers. But right here, you'll find CKAN plugins. And this we already have several plugins installed that CKAN installs by default, which is the statistics, text view, so for text documents, image view, and recline view. I'm not sure what that last one is, to be honest. But it does come with some extensions by default. So we're going to add the ones we've just installed, which are spatial metadata and spatial query, but I'm not in insert mode. So I'm going to add these on here. And this will will turn the two plugins that we've just installed on and essentially put them into the CKAN template, which is very important because this is how you enable the features of plugins. So once you install a plugin, right, it's not enough to pip install it. CKAN doesn't know to look for it, right? So when you do this, when you set these CKAN plugins, it knows to look for that particular Python library, and that's how you tell it that it's doing things. But also, this is where you're going to edit a few things. So we're going to set up the CKAN ext. You can set up the extensions will have functions of their own that we'll need to set. So I'm going to set this to CKAN ext spatial search backend. I'm going to set it to Solr. So that's saying you could also do, again, other backends. So if you wanted to do Elasticsearch, which I've wanted to try for a very long time, but have not had the chance to implement yet, you can actually change the backend. So if we wanted to do spatial querying via Elasticsearch, we could do it here, or we could do it via just PostGIS if you didn't want to do it. There's some options to do it in many other fashions. But again, you see we're editing that spatial plugin based on the prefixes here. We're doing CKAN ext spatial, right? Which means we're actually editing the spatial plugin, not necessarily CKAN itself. So then again, we're going to set the SRID, which is just our coordinate system and our imagery type, to 4326, which is just kind of the standard one they tell me to set it to. And then next, I'm going to do one more thing, which I'm actually going to enable our map servers. I'm going to use Stamen for this one because it's easiest, fastest, and freest. So I'm going to enable you can do it with custom, you can do it with Mapbox, you can do it with any of the other ones that I'm not particularly familiar with, but Stamen is built into it so that you could just call it like this. The other ones you actually have to specify tile servers, which we can talk a little about later if we need to. So that looks good for now, right? We've got our spatial metadata and our spatial query installed. We've got our backend set to Solar, and then we have our tile server set to Stamen. So I'm gonna quit that. Looks like we're good. And the next thing we're gonna edit is kind of annoying. We're going to have to change our Solar schema. Because remember, I talked about earlier that schema XML is symbolically linked to the actual Solar schema. So when I modify this particular schema, we're actually changing the Solar schema in entirety. So we removed the old one, we symbolic link to this one. So we go through here, we look at it, and here's our fields that actually CKAN searches on. So you can see it by CKAN URL, download URL. These are the indexes you can search by normally. So we need to add some to here. And this is all in their documentation, so don't feel like I know what I'm doing. We need to add these ones, which is to add, go ahead and insert. We need to add the bounding box area, the max X, max Y, and then min X and min Y, which is just to specify the bounding box area for our spatial search functions. So I'm going to add that, and then I'm going to do two things. And then we only got one more thing to go before we can actually do the rest. So I'm going to go ahead and sanity check myself and restart Apache so that I know it doesn't give me any errors. And then I'm going to restart Jetty so that I know it also doesn't give me any errors. Jetty takes a long time to restart sometimes. Okay, cool. So before we do all this, we could go back to CKAN now. Where's my Firefox? And refresh it, but it wouldn't give us anything. It would just give us the same functionality we've had before. Let me share real quick just so that I can show what I'm talking about. We have Steve's basic data set, right? But on data.gov, you notice something I talked about earlier, which is that we want this particular mapping function right here, which I think is kind of something. And that's what we did earlier. We searched via the locations, right? We were able to do this. We were able to apply like this. So we have to add this, right? And this is a good extension of, we've added the backend components now for spatial searching, but we haven't necessarily added the front end components for spatial searching yet. So real quick, I'm going to go ahead and add another extension, which will take 2 seconds, ideally. I'm going to go through and I'm going to, let's see. First of all, I'm in our source directory, which is important because this is actually how you manually install a extension. And I'm going to go ahead and clone the extension, which is the spatial UI. Okay, so it's good. Now for ELS, we should be able to see our source there, our spatial UI. Okay, so we're in. So let's go ahead and cd into CKAN-ext. Oops. Spatial UI. So now that we're in there, we're actually just going to do a standard Python setup. So like, all Python packages come with a setup.py. So we're just going to run that on develop. And as you can see, most of the things are already installed because it's just changing some of the templates, the templating engine in CKAN. So we need to go back now, and that we've edited our we've installed a Python library, which is a CKAN extension, but it's not necessarily, CKAN doesn't know it's there yet, right? So we have to go back into our wonderful production file and find our extensions right here. And then go and add one more. Usually, how we name these, the documentation will usually specify their name. I think that's important because I know this because I read the GitHub documentation beforehand. So they have varying names. They don't necessarily always say, like CKAN, or they're not always underscored or something like that. So in this case, right, this one is just spatial UI. I'm going to go ahead, add that. So there's no strict naming convention or anything like that. So we'll go through. Okay, so we're good there. Again, one more sanity check. I'm going to restart Apache 2. Oops, copied too many lines. Restart Apache 2. No errors. Go ahead and refresh this. No errors. Okay, cool. So real quick, let me switch back to my Keto and talk about how we're going to tag things real quick. So, share. Okay, so now we've installed the extensions. We have to talk a little bit about GeoJSON and how we actually tag these particular data sets. Right, so real fast on GeoJSON. GeoJSON is just JSON, but it is with predefined keys for geographical geometry. GeoJSON supports features which can be plotted onto a map, such as a point, a line string, a polygon, a multi-line string, things like that. Things you would normally see on mapping, you know, vectors and stuff like that. You could also add additional keys to an object, which is called a feature. And there's a set of features that's contained in a feature collection. If you're a real dork, you can read the RFC, and that will tell you all the details of the GeoJSON spec. It's fairly easy to read. But just a real quick, an example of GeoJSON. I'm pulling this from geojson.org. And this kind of shows, you know, it's just JSON, right? But it has these specified types, and it has the specified geometry. The keys are all specified for GeoJSON. And then as a feature, we can add additional properties, whatever layer of additional properties we need to. So we don't always need to reference additional properties such as name, or we could take away a feature tag and just reference the geometry itself. So if we just wanted a point with no name, right, we can only reference the geometry, which is actually what I'm going to do when we create the bounding boxes on our spatial data sets. So right here, we have a type point, you know, just kind of showing you can remove a feature aspect from it. But basically, it's just a fast way to show you guys how we're tagging these. We're tagging them with the GeoJSON syntax because that's how the spatial plugin that we added knows how to read things. A lot of times when you're getting a data set, you know ahead of time the GeoJSON, but additionally, if you need to go through and create it, there's a lot of mapping tools, and I'll actually show you guys how I create them as we go through here. So I'm actually going to reference geojson.io, which is going to allow me to make GeoJSON as we go. Okay, so going back into our data sets. Does anyone have any questions while I get this set up real quick? I know, again, I'm going at like a million miles an hour.
Stephen?
Yeah.
This will be available as a recording afterward?
John?
Yep, it's recording right now, and I'll make sure it gets up there, and I'll share it out to the GeoSTL group, so everybody will be able to
awesome. Yeah.
Go back through as many times as you need.
Yeah. I saw it was recording, but I didn't know if it would be available to us for through a link or what.
Yeah, I'll make sure it's put up there.
Thank you. I appreciate it.
Okay, so let me share my screen and we'll go through and we'll actually show you how to tag these now. So let me share Firefox again. Okay, so now, whoops, I already refreshed it. My cool unveil got removed. Now we have the widget that we wanted, right? So now we actually have the spatial search capability. We can go through and we can add something like this and we can apply it and it can say, there's no data sets found here. Because remember, Steve's basic data set was not geospatially tagged, right? So with Steve's basic data set, there's no tag on it, so it's not able to reference that and find anything there. So we need to create some new data sets. And I've done these beforehand just for reference, but I am going to show you guys a fast way to get geo, and you can see popular tags is my name. The fast way to get GeoJSON. So with geojson.io, I'm going to create two feature sets, and I'm going to create two boxes just for fun, so we can pick anywhere. So first, we're going to pick the United States, and this is going to give us the geometry that we need. So I'm going to copy this for now, and I'll show you guys how we use it later. So this is copied, right? And there's our polygon that we talked about earlier. The type is a polygon, and then here are the coordinates, which will give us the bounding box that we've selected, right? So let's go make a new data set. And we're going to tag it this time. So we're going to call this test 1, as I usually have done before. And I'm going to say this is test 1. It's over the United States. And then I'm going to tag this as US, because remember, the tags are infinitely supplyable. You can tag them as whatever you need them to. I'm putting it under Steve's organization. I'm not necessarily going to put any sort of other thing in here. Again, you'd fill under normal circumstances, you'd fill all these out. But here's the important thing I'm going to add to this. I'm going to add the spatial tag, right? And then I'm going to put that GeoJSON that I copied from the other thing, and it's not going to format well, but I'm going to put it into there. And that's referencing that GeoJSON as now a key pair value with spatial. So spatial knows to look for the spatial tag, and it knows how to read GeoJSON. So that's how we're going to get our indexing done via Solr. So I'm going to do is I'm going to go ahead and add data. And I'm going to use, again, we won't talk about this necessarily until the next portion. I'm going to say no data set here, no data type. We're just going to create a dummy data set for this. And I'm going to hit finish. And now you can see that our data set extent is actually previewed in CKAN, right? So it's tagged as the United States. We actually are showing our bounding box inside of the selection that I made earlier. And you can see the data set extent, not necessarily the data set itself yet. We'll get to that. But you can see the data set extent quick, so you can get a quick idea of how the overarching set of it. But then you can also see, oops, didn't mean to scroll out there. Let's use my mouse pad. That spatial tag, right? This is the spatial tag we created, and then there's the polygon that we use, which actually references that. So it, you know, it's relatively straightforward for now. I'm going to go ahead and I'm going to create a second one real quick. I'm going to create test 2, and see where I was testing Solr errors earlier. Test 2, and say this is test 2.
Is the spatial like GeoJSON object, is it always like a minimum bounding rectangle, or
you can do polygon. Certain backends only support certain things, though. That's an important aspect that I appreciate you bringing up, because certain aspects will support points. So like if let's say you choose a different backend that's not Solr, if you use PostGIS just flat normally, it actually isn't going to support multi-polygon or multi-line. It's all in their documentation, but yeah, typically you have to use a polygon, or you can use a point in some. But actually, the default reference is it does not support points. So if you're using Solr, like I am, it's not going to support points. It's only going to support polygons. I'm going to tag this as Germany. And then I'm going to go ahead and make sure it's public, so that it's able to get indexed. Private is essentially setting it to draft mode, because a lot of times there's data clearing it has to go through and stuff like that. So CKAN does support things like that. I'm going to go ahead and add the spatial key. And then what I'm going to do is I'm going to go ahead and go to GeoJSON, hit new, and then I'm going to select one over Germany here. I think I got some of Denmark, some of Austria. I'm going to copy that polygon. Remember, normally you'd have these things structured for you. You'd have the GeoJSON, or you'd have to make the GeoJSON yourself. But this is just a way for me to quickly get GeoJSON objects, because I don't have any to reference necessarily. So again, we have that spatial key. We go through here, we add this, and we hit the add data. The next portion we'll get to is adding data and how to interface with data and resources. For this right now, we'll create another dummy data set. And we're not going to tag it anything because it's not necessarily a type for right now. Hit finish. And now you can see this one's also built out here. So now, if we go through and run CKAN from start and we go to data sets and we're trying to filter, we're able to actually filter the data sets via their location. So if we hit apply, only test 1 shows up, because we're actually doing the spatial query via Solr now. Solr looks at that bounding box and says, okay, is it within this bounding box, right? And since the Germany one, the data set extent is not in that bounding box, right? It only returns the ones that are within that. So all of our data sets are up and working, and that's cool. But there's actually still one more thing we can do. We can actually make it so that we can interact with these data sets. Let's say we get a WMS file to test one. We can actually make it so you can interact with these data sets in CKAN itself via open layers. I'm sorry. So let me go ahead and stop sharing. Let's see if I have any slides about this. Sometimes I do. Okay. Let me share my Keynote. This is a fast install. So share. That's not all. We have the viewer. We can tag geospatial sets in the cool, but what if we have actual geospatial data sets? So like, in one of the cases with Syngenta, we had drone data that was coming through. We needed, it may have been a crop or something like that, or a field that we needed to go through, and they had a data set that was over there, and they stored WMS via GeoServer, and we actually needed to go through and, people needed to visualize that data, right? It's cool to tag it and have it or else, but it'd be cool if you could actually see it in CKAN, right? And that's one of the functionalities we're about to expose. So enter the viewer. The viewer extends the Jin's new templating system to view geospatial data sets using open layers. Real quick, another day, another format. We're going to use something called WMS. I'm not super familiar, or not super sure how familiar people are with WMS. Typically, when I interface with WMS, it's done via GeoServer. But it's an OpenGIS standard which provides an HTTP interface for requesting maps. So you can request layers of maps, and they come back via XML under the hood, but it specifies the tiles, the things that need to be put on it, transparency, stuff like that. It specifies there's a whole stack of things that need to go in. So you could request from a WMS, you could request all the streets in an area, or you could request all the lakes in an area. And that's kind of some of the data we deal with. But with WMS, you're requesting them from a server rather than having the full data set having to maintain in a client application. And this plays really well with our viewer extension. Okay, so without further ado, we'll go ahead and install that so we can go ahead and look at the WMS set. And I have a pretty cool WMS picked out for this. Let me get into my terminal. Good old terminal. All right, so we're here. Now we need to add some stuff in. So we've created our two data sets, and we need to go back real quick because you never want to do things outside of the source directory usually. We're in the source directory, especially when we're installing things, you can see that we have CKAN, base CKAN itself, CKAN ext spatial, and then CKAN ext spatial UI, which are the ones we've installed so far. So now we're going to do something a little bit different. CKAN ext GeoView is a splinter of CKAN ext spatial, but separates the functionality between the two. So we'll go ahead and put CKAN ext GeoView. Now, like I said earlier, as the naming is not standardized, neither is the method of install. You could clone this and pip install it as we did before, or Python install it with just the setup.py and set it specified for development. But this one actually is registered against PyPy, so we can just pip install CKAN ext GeoView. A lot of them will be done like this. Only some of them will you have to get clone and do the actual source install. And again, typically when you're doing a source install, you are going to want to do that so that you can modify the actual code. Okay, so this one's different because it pip installed, and so that means it installs to our Python directory. So this has a dependency that I know specifically is not in its requirements.txt because I've dealt with it before. So I know that for this one, we have to also install CKAN Toolkit, which is a Python library for interacting with CKAN, just wrap some of the functions to make them a little easier to use. So we'll go ahead and install that. And as always, we'll go back to our production INI. And we will modify our production INI to include our viewer. So now we need to add two things with the viewer. We need to add the resource proxy and GeoView as extensions. When you installed that, you actually installed the resource proxy, I think, by default. Okay. Resource proxy might already be in CKAN. Don't hold me to that. So we need to add these two. And resource proxy is just handling caching of resources, so it doesn't have to dynamically load everything every single time, and stores them sometimes inside of the Nginx cache. That way it's not a little faster on the CKAN side for data processing. So now we have that installed. We actually need to do one more thing here. This is interesting because we talked about the default views earlier. The image view, text view, and recline view, we need to add an additional one here. We need to add our geo view, right? Because these are all how you view things. So when we go down here, we need to add geo view to this. And this adds another view for resources. We could have added a docx earlier, right? Which we could have viewed with the image, or a .png, which we could have used with image view. We could have added a text file, which we could have added with text view. I don't know what recline does. But GeoView actually handles our WMS service, and we can specify all sorts of types with it, but we need to modify the actual plugin itself to specify what formats we want it to use. So real quick, I'm going to add an additional line where earlier you saw I modified the spatial extension to specify some things such as the Stamen maps. Here we're going to go down and use this. So we're going to go into GeoView, we're going to go into the Open Layers Viewer, and we're going to specify what formats we want to open with this, right? So the formats we want to use is WMS. You could put KML on here, you could put WFS, you could put GeoJSON. It can support all those types, just to be clear. It supports every type. I'm just doing WMS for this test, but you could also use any other format. So if you export something in KML from something you get, or if you export it in a GeoJSON or any other sort of format, most likely is supported by GeoView or whatever is supported by Open Layers, I'd imagine. It is important to note, I will say, there's also leaflet implementations, so you don't necessarily have to use Open Layers. If you're familiar with those two things, there's a few other implementations as well, which we can talk about afterwards if people are interested, but we can talk about some of the other formats it supports, and I can show the documentation for that. So personally, I like Open Layers. It does exactly what it's supposed to. I find it pretty easy to interact with. And I've also used Leaflet before. So, okay, we save that, right? We're going to go in and we're going to write that, save it. And we're going to restart Apache again because we've made changes. Technically, you usually want to restart every time you modify something. Okay. Now it's restarted. So let's go back. Let me stop sharing here. And look at CKAN itself now, because we're going to have to modify some of our data. All right. So now we're going here. And let's see, we need to create an additional data set. So we've got some of our other data sets set up, right? But now let's say we have a data set that actually has our geospatial information. So we want to go through and add a data set. And we're going to call this WMS test because I'm creative. And we're going to say this is a test of WMS. Say the Earth. And we're going to say viewer, stuff like that. You don't have to put tags in. I just do it out of habit. Public, right? We're going to set that. We're not going to geospatially tag this. We could if we wanted to, but it's the entire Earth. I know because I've already used the data set. So I'm not going to geospatially tag this. But typically, if you wanted to, you could put a spatial tag here and reference it that way. And you typically would, right? Because you know the bounding box and the extent of the WMS. So now we're finally going to come to adding data. So here, we actually have a resource that we want to interact with. So we need to go through here and put in this link, which I already have specified because I know that WMS is existing. Sometimes finding WMSs can be a little tough. And I'm going to put Earth. Shaders. Right? And so this is what this contains. I could put a description if I wanted to, but here's the important thing. In order to tell CKAN what type of viewer to use, you actually have to put the type here. So remember, this is a WMS file type, right? Where we're getting back is an XML, which just like GeoJSON has these specific functions or specific tags that it necessarily needs. So if we put WMS here, right, it's going to tell CKAN, okay, this is WMS. Remember, we specified in that Open Layers thing, if it's a WMS, use this particular view, right? So now when we hit finish, we go through here, we have Earth shaders, Earth viewers. If we go into Earth shaders, we actually have the WMS data set that we have. So now you can interact with the WMS data set via open layers. So if we wanted to activate the secondary grid, we could do that. Or if we're going to activate the shaders, we could activate that. And additionally, all these like open layers will have a base level, which we specified earlier to be Stamen, right? So it's going to use the Stamen tile set, tile server to do this. So you can interact this. This is one I chose that just had all the information in it. The controls are already bound usually. So going over certain data sets, you know, you can see the topographical information. But it gives you a way to interact with the actual data set, and it doesn't have to be as big as this one particularly, but it gives you a good way to interact with the data set that, you know, you don't have to leave CKAN and go somewhere else. And so there's a lot of, you know, I'm just going to zoom out here just to kind of show, you know, what you can get. You can get pretty dang clear on the geographical imagery that you can produce in here.
It's really nice.
Yeah. Yeah, and then you can, you know, you can do things like this will give you the actual link to CKAN, so you can embed it in other applications. Again, everyone can use this via API. API will actually interact, so you could have these data sets. You know, you can go full screen with this if you wanted to. I know it doesn't seem like much, but you know, you can do a lot of really cool stuff with CKAN in this OL viewer. But it's just another way to interact with CKAN and geospatial. So that's, you know, kind of it. I mean, we've gone from absolutely nothing, having, you know, a Blake Ubuntu image, to having a full geospatial capability and running and being able to interact with WMS files and search against them. So let me share my screen. Doesn't really matter. I just have my corny joke I wrote. Boom. Anyways, if you guys have any questions, I mean, let me know. You know, what do you guys want to talk about? I know I went through a lot of stuff really fast, so.
What other extensions do you normally use?
Typically we run, there's a security extension that runs two-factor authentication that we've used in the past. It's done by the Australian government, I believe, and they use CKAN for their equivalent of data.gov, which they have a two-factor authentication one. We have also used Pages in the past, which allows for simple modifications for static pages, so users could blog on it. We've used something called CKAN EXT scheming, which is the ability to quickly override schemas for data sets. So you could add, you know, any additional amount of, you know, right now you can add like an author, right? You could make it so you could add 6 authors, and you would just import the data set via schema via JSON. Let me think. I think those are the ones I can think off the top of my head. Typically, we interface a lot with that, and then we usually, when we're implementing it for like Bear or someone else like that, we typically create a theme, right? And we go through and we actually modify the whole CKAN instance to look different, completely different. Because, like, you know, data.gov doesn't look anything like what I showed you guys other than the widgets, right? So they have a theme. There's a whole templating system to CKAN. So you override like the home page and stuff like that. So typically, you know, the structure is to use some that are beneficial, like this geospatial stuff, but then also write your own theme to kind of modify the HTML to look like you want it to now look.
What's the most?
Sorry.
Go ahead.
Are there any limitations of data types that you can use?
Not particularly. And typically, if you wanted to implement something on your own, I would just write a CKAN extension for it, honestly. Let's say you wanted to implement, you know, something that's not standard and it doesn't, no one's used before, like a YAML file, right? If you wanted to start a YAML file, you could just write an extension. And then what I would do is I would use PyYAML. I'd plug it into the CKAN extension, and I'd make a viewer out of that. But there's no limit to what you can put up there, as long as the data set, the tags. So the way that those formats are generated, like when I typed in WMS for this one, those are just tags under the hood. It's just certain viewers will recognize them. So that particular OL viewer or GeoView recognizes WMS files that it should use. But you can tag HTML, you know, any other data set that you'd be able to use, or any other data type, I'm sorry, you'd be able to use.
Okay.
What are some best practices or common mistakes to avoid when administering CKAN or curating the data in it?
Yeah, I have to think about it, but I think one of the big ones is data cleaning. The best practice, obviously, is to limit the amount of people, obviously, they can modify data sets. You don't want everyone to be able to modify everyone's data. Another good way, keeping the organizations very focused and maintaining tags is another big thing. A lot of people will, as is a tendency with any application, right, is when you're going through data, we've in the past enforced certain things be filled out. So, no one's really keen on tagging, right, in their data set. So we could enforce like you have to have 5 tags on it. Or I know in the past we've also enforced that the maintainer email has to be filled out, otherwise you can't post it. And that's just so that some people have references. If you're going through something and looking at, you have a reference for who you can reach out to get a hold of this data set. Those aren't by default mandatory, but I found that that's typically, it all comes down to data curation and enabling what creates the cleanest interface for people.
So if you had to, you could go in there and enforce required pieces of metadata in order to reach some level of compliance with the organizational standards.
Right.
Cool.
Yeah, absolutely. And when you belong to a group, by default, CKAN doesn't allow you to go in and edit other groups. So, and there's also, not everyone is a sysadmin. There's also group admins and organizational admins and another admin tier above that, I believe. So you can give people the ability to edit only their administration or their organization, I'm sorry. But you can also give them, they can't go in and just change another data set. And so keeping those very clear and then maintaining who owns the data set, because a lot of times what we found, especially in some of our clients, is that they need to reach out to someone once they have a data set and there's more questions about it or how to obtain it or when's it updated or something that doesn't get shown in CKAN. There's usually a good way to track down that person.
So one question I had as far as so we're looking at data.gov that's using this and they have hundreds of thousands of data sets. The thing is how adding a data set is as simple as dropping a URL in there. I mean, is there any kind of utility that exists in order to ensure because I could see it being super easy that trying to maintain 100,000 data URLs, they're going to expire and they're going to get old and the data is just not going to actually be there. And then people aren't going to go back and remember to update them all. And so at some point it feels like you'll end up with a catalog with a whole bunch of dead data.
Yep.
So I was wondering how do you combat that? Is there a utility that goes and runs a check against the URLs just to make sure they get some kind of a valid response, or is there any good way of doing that?
Yeah, there's something called the CKAN ext harvester, which the way harvesters work is they run against a given API, and they run like cron jobs basically, where they have a scraper that goes through and inputs that API nightly or as frequently as you want it to. I guess as much as frequently as you have the computing power to do so. But that will update your data sets and that will maintain a data set. So it's an extension. Spatial harvesters are out there. There's different harvesters. We've written harvesters for Bear. They go through their internal services and against those APIs, and then will invalidate data that no longer exists. Or it basically comparative, it pulls back a series of objects from whatever API it's scraping, and then we'll class that against what it currently has. And it takes a little bit of elbow grease to get there sometimes, but it's definitely a feature. And we've used, in a lot of our implementation, we've used harvesters. That's something I wish I could talk a little more on. Maybe sometime down the line, we can talk about spatial harvesting and harvesting data via CKAN harvesters. It's an extension.
When you say invalidate a data set, do the data sets have different statuses that you can set them? Okay.
Yeah. So actually, it's pretty cool the way it works. I don't have my database explorer open right now. I don't have data grip open, but whenever you modify a data set, it actually gets stored in a package revision table. They're called packages under the hood, and it gets stored in a package revision table. And so every modification you make to it, let's say you update the user or the maintainer, or you update the bounds, right? That's stored in incrementally. So you could actually roll back a data set. to another version of it because it's stored in a revision table, right? And so every time you modify it, it's stored in that revision table. And that it also has states of active, deleted. So they maintain a database so you don't necessarily lose them. If someone accidentally deletes them or something like that, which, sometimes can seem impossible, but you don't necessarily lose them. They're set to deactive or deleted or something like that. And those will show up in revisions, as well as any other modification that happens to a data set.
Cool. Is that so? Somebody who's, I know you can like watch like an organization or whatever. Can you do the same sort of watching of a data set? So whenever a version sort of an update happens, that the data that you're referencing somewhere has changed.
Yep. If we look at our WMS, zoomed in. If we go to our WMS test, you can follow. And that follow will send you incremental updates. You might have to plug in some email stuff, but that will give you updates on your activity feed. Activity stream will give you updates on the stuff that you're following inside of CKAN. But you can also, there's some extensions that we've plugged in before for emails, automated emailing people when their data set, you could put like a timer on it, like you have to update by this, and you're the maintainer for this, so you could automatically do that. We've done that before with emailing too, where if you you get an email of these data sets have been updated every so often. Typically, we've done some stuff before in the past with Yammer. And I think sometimes, those consistent updates can get a little tough because if you have a very large data pool, then you're getting a lot of updates through channels that I think tend to get ignored. So I've always preferred the digest email approach in that respect.
Super cool.
Yeah, it's super powerful.
I was going to say, it really does so much.
Yeah, it does a lot. I will say, for us, it's been incredible. It really has. I'm a big proponent of open source, like I said at the beginning, and CKAN's open source abilities are pretty unparalleled for a data management system. You can really, one of the things I think you notice off the bat, right, is it's not necessarily great looking, but you can change all that. We've done some pretty good modifications. Data.gov doesn't look horrific, right? But you can modify it, update Bootstrap. Something I've wanted to do for a very long time is put a React front end on it, give the data the data processing and data interaction a little more power, kind of put a progressive web app face on it. So, I think the only downfall that we've had with it sometimes is the Jinja 2 templating system can be tough. Sometimes you want to do things a little more interactively than Jinja 2 allows for, but for the most part, we've been able to get around that and modify it. And again, if you need to remove something or add something, it's just as simple as creating an extension that adds or removes it.
And you said you guys have been leveraging this for the PPE initiative. Is that right?
Yeah. So we did an initial documentation where I think it was the T-Rex had us come out, and we needed to spin something up fast that would categorize. And this is for hospitals as a particular instance, that would categorize either a PPE distributor or someone who needs PPE, a consumer, right? And so what we did was we started aggregating businesses around us that could produce PPE, and we were tagging them essentially as producers. And then you could go in there and search for producers, and then you could search for consumers. And then we were adding those additional extras where we'd add spatial as the amount of face masks they were able to produce, the amount of face masks they've needed. Just stuff like that. It was a really quick implementation. We plugged Leaflet into it too, just to kind of do some overarching map stuff for it. But yeah, we've stuck it in a bunch of places. We've created an ordering system out of it that processed every order as a data set and then maintained those orders in that manner. So we've done, it really is it's a cool framework. It does, you can bend it to your will, so to speak. Pretty quick, I would add.
That's really cool. Yeah. Anybody got anything else? This has been super neat.
Sweet, thanks. Yeah, I love doing it. So I do it, most of my applications are done for this and data management. And so it's just it's a really cool way to handle it.
Awesome. So yeah, what I'll do, once we wrap up here, the recording will take a while to process. So sometime tomorrow, I'll shoot out a link to everybody that basically RSVP'd to this. So that way, people that wanted to come and missed it will get a chance to work their way through it, and then the rest of us can scroll through it again and again and again and get a bunch of stuff stood up.
Yeah, and I'll post a script. Andrew mentioned, and I agree that that's something that I'll post my script for doing all this stuff, so you could just run in a shell script. Besides some of the modifications you need to make to the INI files.
Awesome.
Thank you very much.
Really appreciate it, Stephen.
Thank you, guys. I appreciate you coming and listen to me, watch me apt-get install things for an hour.
Thank you.
Cool. All right. I guess I'm guessing that's a wrap. So yeah, Steve, thank you so much for putting this on.
Thank you guys for having me, man. Anytime. I'll be at all the rest of the meetings, so I'll see you guys around, I'm sure.
Outstanding. All right, folks. Really appreciate it.
Later, guys.
Thanks much.